Hey, how's it going? It's Joe. Let's see, today I wanted to talk about building a quantizer in the ER-301 for an external offset. So I've got this little sequence playing a sample. I'll let you listen to it. And I've got an external offset coming off of the IntelliGel quadrat, so it's a -5 to +5 volt signal, and it's controlling the speed. So here's the signal on A1, and you'll notice if I sweep it up and down, it's a continuous signal, right? But if we come back up here to the speed control, as I sweep that knob, you'll notice that it's not hitting every value continuously as we go, right? So it's just stopping at some interesting values like 0.25, 0.5, 0.75, 1, 1.5, 2, and 3. And then it's got the negative versions of those as well. This allows us to just kind of twist a knob, and as I'm playing the sequence, I'll just kind of demonstrate it here. This was Cosmic Sound Explorer's idea on the forum, so just kind of trying to figure out how to set this up. I'll kind of demonstrate it here. And down here we go backward. So that's kind of how it works. So the way we've set this up, and this was Brian's idea, was to use this sample scanner. And what we're doing is using the sample scanner as a transfer function. So we've got the sample in here that corresponds to the various values that I want to hit. So as I twist that knob, we have a continuous voltage coming in the left-hand side over here, and we've got discrete values that are coming out the right-hand side. And I actually built this transfer function, which is a wave file, using the ER-301, so that's what we're really going to focus most of the time on today, is kind of how to use the ER-301 to build a sample file such as this one. Just to kind of demonstrate over here as well, I will mute this channel here, and you can kind of watch here in the bottom display as I sweep this continuous voltage up from bottom to top. It's really just kind of making discrete stops there along the way, right? And that corresponds to, you know, the various speeds that we've got up here on the speed control. Let's see, so just to kind of review the sample scanner, let's go up here and do a global chain, and we'll just add a new global chain up here, call it whatever. And we'll insert a sample scanner unit, and I'm going to load. I've got, where did I put this here? Okay, so this is the right waveform. So this is just a linear ramp. So the way this sample scanner works, you can see this is a very short sample, and it's just a linear line going up. So the input is the x-axis, left to right here, and then the output is going to be the y-axis. So you can see if we've got like a value of -1 coming in here, and we see where that corresponds on this line, you're going to get a value of -1 out. If we come over here to the right and we are at a value of 1 coming in, then we can see where that intersects the line, and we've got a 1 coming out. If we're at 0, we've got a 0 coming out. So this is just kind of like a straight transfer function. Basically what goes in is what comes out. At least if the sample scanner is set up with some settings like a width of 1, which means to use the whole waveform. And we're going to turn this crossfade off and make that a 0. So this is kind of the sample scanner config that we're going to use. But instead of using a linear transfer function like the one we've got here, we've created, back on the channel chain, whoop, wrong place there, back on the channel chain in this sample scanner, our transfer function. So what comes in is not what goes out with this one. So I think that's kind of the overview, and next I want to get into building this waveform. Okay, so we've got to do just a little bit of math here. We're going to be recording to a WAV file. So we really, don't want to have any values that are bigger than -1 or between. We want the values to be between -1 and +1, basically, right? Otherwise, they're going to clip. I haven't actually tested that, but I'm pretty sure it's right, so I'm not inclined to test it. The values that we actually want to get out, are going to correspond to things like -3 up through value 3. So I've typed them out here. You can see them. These are all the values, all the stops that we want to hit on the speed control. So basically, we want to normalize these, right? We're going to have a 3 gain going into the speed control. So basically, we just want to divide all these things by 3, right? So we'll do this divided by 3. And what we can do is just take the cell and copy it, and take the cell and copy it, not cut it. And we'll just paste this down here. And this should give us all the values that we actually need to record into that WAV file. So these, you'll notice here, let's see, we're down here at row 15. We've got kind of one header row up here, so we've got 14 values. So the sample scanner doesn't really care how long the sample is. It's just gonna, if you get the width set to 1, it's gonna, basically recognize that as however long that sample is to be sort of the entire length of the input. So we've got 14 samples here. I'm just going to maybe choose an arbitrary length for each of these samples, and I'm going to set that to be 100 milliseconds or 0.1. And we know here that we've got 14 samples. And so we'll just put in another formula here, and we'll say this times this. And so that gives me a total sample length that we're going to record here of 1.4 seconds. So 1.4 seconds, each segment is going to be 100 milliseconds or 0.1 seconds long. And down here in column C, these are the values that I'm going to put into it. Okay, back to the 301. Okay, let's actually build up this transfer function, this WAV file or sample. I'm going to create a new global chain, and I'm just going to call it, whatever. This is just going to be a throwaway chain that we're just kind of using as a working area. And I'm going to insert a dub looper. So the first thing I want to do, we said we want the sample to be 1.4 seconds long in total, and we want each sample to be 0.1 seconds long. So we do need to create kind of a gate or something that's going to be like 0.1 second increments. So that's what I'm going to do first. So I've got this dub looper in here. I've got the dub set up to 0.1, which is what we care about. So I'm going to create a new buffer here, and I'm going to make this 100 milliseconds long. And we'll just create that, and I want to insert an offset unit here. And you could set this to 1. I'm going to set this to 0.9 or something, just so we can see it. And we'll engage this looper, and we'll punch it. And, we just have to punch it for 0.1 milliseconds or longer. And you can kind of see right there up at the very top, we've got our our 0.9 value has been recorded there. So let's see here. Oh yeah, so this is we've got the sample in here. It's in the buffer. We're going to need to go back up here and into the sample pool. And I've got this. This is going to be, looks like this is temp buffer 2. Let's do save as. And I've actually made a folder here for myself called gates. And you can kind of see where I had done this before. I've got one called gate 100 milliseconds. So we'll just go ahead and overwrite this one. Okay. Let's see, so back onto the recording of the actual sample now. So we'll go back into this global chain. We can just delete this unit, and we'll just leave the offset setting there. That'll be handy. We'll insert a new dub looper. Dub is set to 1. So let's go in and configure some settings here. We're going to turn the engage latch off, and we'll leave the punch latch on. So that should be good there. We're going to create a new buffer. This one's going to be 1.4 seconds long. This is going to be our final sample. So let's just crank this up here. To 1.4 seconds. 1.4 second mono buffer. So that's what we'll create. Let's see here. So I'm going to go ahead and we'll just leave the punch engaged. And for the engage here, we're going to create a chain. And for this one, I am going to insert, we're going to use a raw player. And for my sample, I'm going to select from, it should still be in my pool here, I'm going to use this 100 millisecond gate. And we'll turn the crossfade off. And one thing I want to do here, so this thing is like at a value of 0.9 all the time. I'm going to come in here into the slice menu. And let's see here, it looks like we are looping. Let's stop that. Let's go into the options. We'll set the play duration to once. And we'll come back up here and we'll go into the slice menu. And what I want to do is just go over to the very end of this sample. And I'm going to hold down. Alrighty, there, got interrupted there, but so yeah, we need to basically this sample is all at 0.9, so that's where it'll kind of hang at the end. So what we're gonna do is just come over here to the very end, hold down the shift key, so that selects, right? We're just gonna select just like the very minimum we can there. Just got a very small selection on the end. I think you can see the selection in here, can't you? And we got the head at 0.99, so yeah, I think we're at the smallest selection we can possibly have. We'll go to menu, and we'll choose silence. Silencing the selection, are you sure? Yes. Okay, so now we've got this 100 millisecond gate. And what I'm going to do, I'm going to hook this up to an external controller. So I've got a gate coming in. I think it's on G2. Yep, that's just from my BeatStep Pro. So we'll pick that, and that's just kind of for convenience, right? So just kind of monitoring the output here on the lower display. When I hit that button, I get a 1 millisecond gate signal. And all right, so let's reset this buffer. I'm just going to fire the reset, and we'll just go in here to the engage control and just kind of watch it, right? So as I hit that, you can see it just advances 1 millisecond. The engage comes on, and then it pops back off. So I can do that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 times, and that pretty much takes me right up to the end. So I'm going to be able to record 14 samples in here that way. So let's go ahead and reset this one more time. And I've got my offset over here, and now I'm going to refer to the table of voltages that we had calculated on the spreadsheet. Let's see here. So the first value is going to be at -1. So we'll dial that in here, and I'm just going to hit that external trigger to record that. And the next value is at -0.667. So we'll dial that in, and I'll probably have to switch into fine mode here. And I might even have to hold down the shift key to go even finer to get the exact right value. So there's 0.667. I'll fire my trigger again. The next value is -0.5. And again, probably have to hold down the shift key here to get it exactly, and I'll hit the trigger again. And just to kind of show you what's happening here as we record this, so we're starting to record these values here into the sample, right? We've got the 0, the -1, minus 0.667, there's the minus 0.5 right on the money. So I'm going to record the rest of these samples. I'm probably just going to be silent here as I do it, and we'll probably do this part of the video in, like, super warp speed motion because it's going to get a little boring, but I'll just go ahead and finish these up. Alrighty, so if we go take a look at it now, we've got this stair-stepped waveform that contains all the values that we calculated out. Looking good. So I'm going to go ahead and come up out of here and back into my sample pool management. So we've got this buffer 4. I'm going to do a save as. And I've created a folder out here called transfer function, xfer function, to store these kind of things. And you can see before here I had, when I worked this out, made this thing called speed map. We'll just go ahead and overwrite this. Cool. And let's flip back out into the channel chain, and now I can come in here and insert my variable speed player. And we'll go to the speed control. We'll go ahead and zero out the bias. And to control it, let's see, first we'll select my offset, which I think was on A1, yep. So there's my -5 to 5 volt signal. And so now we're going to insert this sample scanner unit, which is down here in the mapping functions. So there's the sample scanner. All right, so we're going to set the width up to 1, which will mean, use the entire sample. We're going to set the height to 1, which is basically kind of a unity gain of the sample values coming out. And we'll set this crossfade to 0. And let's see, for the card here, we are going to, actually this is still in the sample pool, so we'll just pick the speed map here. Select that sample. And what I've noticed is that the sample scanner kind of has an internal gain of 2.0 when it hits it. So I kind of thought I might have to double the signal here because it goes from, -5 to 5. And the sample scanner is really reading from like -1 to 1, but it actually does kind of multiply by 2 on the way in. So it's going to be fine if we just leave this alone with this -5 to 5 volt signal. It's actually set up for that. So we'll come back up here, and then we're going to set our gain on the speed. So we've got values of -1 to 1 coming out, and we want to set that up to a gain of 3. Chain. Let's select from card. And let's make sure that looks right. I think that's right, so let's zoom on that. I'm going to hold down the course key here. And that looks like our transfer function. Okay, let's see. So let's check out if that worked. So there I've got -3, -2, -1.5, -1, -0.75, 0.5, 0.25, 0.25 positive, 0.5, 0.7, 1, 1.5, 2, and 3. So we've got a little space on the end there where it jumps to a strange value, kind of 2.7, and I think that's because, you know, the gate just wasn't quite exact. It was just like, you know, 1 millisecond short of being that. So I think we could probably edit this sample, right, and, you know, kind of trim off the ends of this thing if we wanted to be that picky about it. There we go. So I think what we could do is just come in here. Like I said, the sample scanner is not, you know, particularly picky about how long the sample is. So if we wanted to just kind of come in here and select this last little part here, go into the menu, and we could cut that out. And we could do the same thing on the first part of it if we want to. So just select a little bit here, and go into the menu, and we'll just cut that. And now if I turn the knob all the way to the left, we get minus, I've still got a little funkiness there where it jumps up to 3. Okay, so I think what's going on here is that as I roll this voltage down all the way to what I think is -5, I think it may be going just even a little below that. See how it's kind of wrapping back around this side and the head is going over here. So I think the way I'm going to try to fix this is by attenuating this input signal just a little bit. So let's put a linear bipolar VCA in here, and let's set the gain up to like just short of 1, like maybe, let's even go into fine mode here and try like 0.994. And that may not be enough. Let's try like 0.975-ish. There we go. And so a little bit of massaging there, but I think that solves the problem. That knob is all the way down now, and it hard locks at -3. And as I scroll it up to the top, it stops right at 3. So I think mission accomplished. So just to kind of review what we did there, you know, we kind of mapped this out and, you know, picked the values that we wanted to stop at, and just used a spreadsheet to kind of normalize those to, you know, values that fall between -1 and 1. We figured out how many samples we had, and so we figured out kind of the sample length and the total length of our sample. We created ourselves a sample that was a gate that was basically as long as we want each sample to be, and then we used that gate to back up here in the admin area. Use that gate to trigger the engage control, which is not punched, not latched. And then we just used an offset to record those values into it. Anyway, I think that's it. That's the end of the tutorial. Thanks for watching. Hope you learned something, and hope this is useful for you. Take care.